Hello, this is Guande from New York University, and I'm really happy to present our Qian paper, ARTiST, Automatic Text Simplification for Task Guidance in Augmented Reality. The human users often complete tasks by reading and following the given procedures. AR headsets such as HoloLens can project the instructions onto the real-world environment, offering an immersive experience. However, when using the AR headsets, users may suffer from the higher cognitive load and the lower attention level. The instructional text, which is clear on the paper, may be much more difficult to read when being placed in AR headsets. Text simplification becomes a viable solution to this problem. It allows us to distill the text into more understandable and concise forms based on the original procedures and the user's current environment. Text simplification is actually not a new concept. Instead, there's a large body of research in natural language processing community. Let's take a look at this sentence. Archaeologists unearthed evidence illustrating the lifestyles of ancient civilizations and their cosmological beliefs in Côte d'Ivoire, discovering a secret guide to the past. To simplify the text, we can use the lexical simplification, which replaces the complicated words by a simpler ones. For example, we can replace the word unearthed by the word found, or we can replace the word elucidating by the word revealing. The second technique we have is the content reduction, which removes the redundant words and phrases from the original text. For example, here we remove the sentence, discovering a secret guide to the past. The third technique we have is syntactic reduction, which simplifies the grammar structures of the original text. For example, in this sentence, we split the sentence into two to make the sentence more readable. The final technique is the elaborative simplification, which elaborates on some difficult words. For example, here we added the elaboration on the word Côte d'Ivoire by a country in West Africa. To sum up, the traditional text simplification in NLP community typically involves the four techniques: content reduction, syntactic, lexical, and elaborate simplifications. However, applying the text simplification directly on AR task guidance is challenging. The first challenge we have is that the AR task guidance has a really different form of the text. For example, in the recipe of making a coffee, we have the text like lift up the dripper and pour out the water. We can see that this text is more related to the specific actions and objects. Another challenge is that AR text guidance has a very different target audience. In traditional text simplification, we may focus more on the second language learners and children. However, in task guidance, we may focus more on the skilled workers under the higher cognitive load. As a result, the takeaway here is traditional text simplification does not apply to the AR task guidance. Therefore, we conduct a formal study to understand how to apply text simplification in augmented reality properly. We first conduct an expert interview and ask their feedback on the traditional text simplification and the AR task guidance. This interview addressed the expert's background and experience, the challenges of AR text interface design, the assessment of the need for the text simplification, and the potential benefits and the drawback associated with it. So, we just list a series of findings from the expert interview. The first finding is all experts recognize the need for simplified the text. For example, the E2 suggests that reading the long text may make the user anxious. So we need to have to shorter text and makes the task more efficient. However, we also observe that text simplification may be risky for losing the important information. As E2 also pinpoint that when working with a mechanical system in real-world scenarios, failure to follow instructions accurately could lead to catastrophic consequences. We provide the examples and the definitions about the four simplification techniques and ask their feedbacks. It turns out that all the experts agree on the benefits of the syntactic and the elaborate simplification, while the opinions on the content reduction and the lexical simplification vary among the experts. We further conducted an overnight exploration with 7 participants to validate the insights obtained from the expert interview. Based on the feedback from the expert interview and the open-ended exploration, we compiled 3 design guidelines to support our system design. The first guideline is meaning preservation is paramount in text simplification. We cannot lose any important information in the text. The second design guideline is text simplification must consider both AR-specific challenges, such as the issues with FOV and cognitive load, while exploring the AR-specific opportunities. The third design guideline is that the text simplification in AR should give priority to text length over grammatical correctness. This is pretty interesting because we observe that the participants in AR experiments can still understand the instructions even though the sentence is not grammatically correct. After we know what we should consider in text simplification for AR, we face another challenge: how to implement it. Since this is a new problem, we have 0 annotated dataset for training a new model. However, thanks to the GPT series language models, we can now directly integrate the new design knowledge into it and prompt it to help us to simplify the text. The GPT series model still faces a serious challenges such as hallucination and the unsteady output. We've offered some solutions to make it a better model for text simplification. The first method is plan of technique, treating the 4 simplification techniques as units of plan. The model is prompted to select a set of applicable techniques for any input text. Our second method involves the train of thought prompting, a well-established technique that integrates the explanation into the inference process to guide the model's reasoning. We observe that the train of thought can significantly improve the reasoning quality of the GPT models. Lastly, we employ error-aware calibration to adjust the output text by identifying and correcting the potential errors in the output. For example, in the figure, we remove the output that grind beans until the sender consistently calls because it loses the important information 20 seconds. To evaluate our approach, we conduct a user study with 16 participants. Our user study aims to evaluate the 3 research questions. The first is, in what ways does our proposed method impact cognitive load in AR? The second research question is, in what ways does our proposed method affect task performance with text in AR? The third research question is, how does our proposed method compare to other text simplification methods in AR? In the evaluation, we set 2 user studies. The first user study focuses on the longer task where the user needs to prepare the coffee and the meeting room. We compare the baseline condition and our approach. The study results reveal that our approach has the reduced cognitive load and less errors made in the task, showing the effectiveness of our approach. In the second study, we asked the participant to edit the video based on the instructions showing HoloLens. We added 3 new conditions, which are the oversimplification, undersimplification, as well as the traditional simplification techniques. We find that the simplified text generally indicated better performance. However, for the oversimplification condition, it receives very distinct feedback. Some participants favor it because it is very clear and short. However, others may feel it too simple and miss some important information. This further validates our first design guideline. In conclusion, our work aims to provide a better reading experience in AR by simplifying the text. This research represents one step towards a more human-centered AR interactions and a better AR text presentation. Looking behind, there is efforts working towards a better AR text display, including using better text placement algorithm and using better text fonts. Also, there is some related work which focus on adapt the text to the context of the user. We believe that the AR reading experience is very different from the traditional medium, and we think the special method should be developed to support such reading experience. In the future, we think we should have the cognitive load-aware text simplification method to better assist the user in reading the complicated text. Also, we may need to think about the context-aware text presentation to better align with the actual environment. Furthermore, the new font can be designed to adapt to the AR-specific environment. Finally, we summarize the takeaways from this presentation. The first takeaway is we should consider the text application adapted for AR in designing the AR display applications. We believe this method can be generalizable into different AR applications such as navigation. Secondly, we open source our detailed design guidelines and our application and welcome to use our application. Finally, large language models offers a new opportunity for HCI researchers, as now we can integrate the new design knowledge into the prototype in just a few days. This work was supported by the DARPA PhD program. Any opinions, findings, and conclusions or recommendations expressed in this material are those of the authors and do not necessarily reflect the views of DARPA. We thank Xiaoan Liu, Jeff Huang, James Topkin, Leslie Welsh, and Ashley Gitty for their contribution and insightful feedback. Thank you so much for your watching.